Howdy! In this mini lecture we will discuss the hole in the ozone layer, acid rain, and indoor air pollutants. The student learning objectives of this mini lecture are: explain stratospheric ozone depletion and identify steps to address it, define acid deposition, illustrate its consequences, and explain how we are addressing it, and characterize indoor air pollution and assess solutions. Recall that ozone in the lower stratosphere absorbs the sun's ultraviolet UV radiation. Without the ozone in the stratosphere, a great deal more UV radiation would reach the Earth and cause damage to biological tissues and DNA. Air pollution we produce, however, has caused the ozone layer to become thinner, and in some places, holes have formed in the ozone layer. The pollutants that cause this damage are called ozone-depleting substances. These are human-made chemicals that destroy ozone. The two main culprits are halocarbons and chlorofluorocarbons. Halocarbons are human-made compounds made from hydrocarbons with added chlorine, bromine, and fluorine. Chlorofluorocarbons, also known as CFCs, are halocarbons used as refrigerants, in fire extinguishers, in aerosol cans, etc. CFCs were widely used once because they have incredibly high boiling points, which means they could be used near high heat sources without the risk of them catching fire. Recall from earlier in this mini lecture that some pollutants have a very long residency time. CFCs and halocarbons are compounds that stay in the stratosphere for at least a century. We assumed CFCs were harmless because CFCs rarely react with other chemicals. But because they are non-reactive, they reach stratosphere unchanged and can linger there for a century or more. CFCs essentially strips ozone of one of its three oxygen molecules. When this happens, ozone is turned into O2, which doesn't have the same UV absorption and reflection qualities. The problem with CFCs is that one molecule of CFC can destroy 100,000 molecules of ozone, and since CFCs stay in the atmosphere for centuries, this problem is difficult to stop once it's started. The ozone hole is a vast area of thinned ozone in the stratosphere situated over the Antarctic region. Please understand that ozone depletion lets in more UV rays, but this doesn't appreciably warm or cool the atmosphere. Also, there is a misconception regarding the ozone hole and global warming. The common misbeliefs are that depletion of stratospheric ozone helps to prevent global warming by letting heat or gases out, and ozone depletion lets heat into the atmosphere. Both of these are untrue. Although the Antarctic ozone hole grew quickly after it was observed in 1985, the phase-out of ozone-depleting compounds beginning in 1987 has stopped the growth of the thinned area of ozone. The Montreal Protocol of 1987 is the main reason why this happened. In 1987, 196 nations signed the protocol and agreed to cut CFC production in half by 1998. Later agreements deepened cuts, advanced timetables, and addressed other ozone-depleting chemicals. Following the Montreal Protocol, industry shifted to safer alternative chemicals. Although we stopped the Antarctic ozone hole from getting worse, we still face challenges because CFCs will remain in the stratosphere for decades or longer. We can remain positive, though, because the Montreal Protocol can serve as a model for international environmental cooperation. Let's now turn our attention to the problem of acid deposition, commonly known as acid rain. Acid deposition is the deposition of acid or acid-forming pollutants from the atmosphere onto Earth's surface. A simple way to think of this is that acid precipitation is any form of precipitation that is more acidic than normal. Acid deposition is one type of atmospheric deposition, which is a broad term referring to the wet or dry deposition of a wide variety of pollutants, including mercury, nitrates, and sulfur. Acid precipitation is an example of a secondary pollutant because it is formed from primary pollutants. For example, industries that burn fossil fuels emit sulfur dioxide and nitric oxide into the atmosphere. These pollutants combine with water, oxygen, and other oxidants to form sulfuric acid and nitric acid, which fall to the earth from the atmosphere in the form of acid rain. Acid rain has a variety of impacts on the earth. The following are the main effects of acid rain. It causes nutrient to leach from topsoil, changes soil chemistry, converts toxic metal ions such as aluminum and zinc into soluble forms that pollute water, affects surface water and kills fish, damages crops, erodes stone buildings, corrodes cars, and erases writings on tombstones. We have reduced acid rain through the Clean Air Act amendments of 1990. These amendments established an emissions trading program for sulfur dioxide that drastically reduced incidences of acid rain. New technologies such as scrubbers have also helped. Altogether, policies and regulations have lowered U.S. emissions of sulfur and nitrogen oxides 43% since 1989. However, like many environmental problems, acid deposition is worsening in the developing world. For example, Coal-burning China emits the most sulfur dioxide and has the world's worst acid rain problem. Although we have focused thus far on outdoor air pollution, it is important to recognize that there are significant threats to our health brought on by indoor air pollution found in workplaces, schools, homes, and other buildings we spend a lot of our time in. Considering we spend 90% of our time indoors, we should be aware of the air pollutants we are exposed to while there. The World Health Organization estimates that 3.5 million people die prematurely because of indoor air pollution. Compare this number to the 3.3 million people who die from outdoor air pollution, and it's clear to see indoor air pollution is just as significant as outdoor air pollution. In developing countries, the major indoor air pollutants are produced from burning wood, charcoal, manure, and crop waste for heat and cooking. The buildings in developing countries usually lack adequate ventilation, so people are exposed to dangerous amounts of soot, carbon monoxide, and other pollutants. In developed countries, the major air pollutants of concern are tobacco smoke, radon, and VOCs. In many places, though, smoking is no longer permitted indoors, so this helps to reduce the risks associated with this pollutant. Radon is a natural radioactive gas that is formed by the decay of uranium in the soil, rock, or water beneath a building. You should also be aware that indoor air pollution can be caused by tiny living organisms. Dust mites, airborne spores of fungi, molds, and mildews can cause allergies, asthma, and other respiratory problems. Microbes that induce allergic reactions are suspected of being the main cause of sick building syndrome. This is a sickness produced by indoor pollution for which the specific cause is not identified, but it is hypothesized that microbes and VOCs play a significant role in this illness. To keep yourself safe from indoor air pollutants and sick building syndrome, you can limit use of plastics and treated wood, use low toxicity building material, furnishings, and products, limit exposure to toxic substances, test home and offices for radon and mold, use carbon monoxide detectors, and keep rooms and air ducts clean and free of dust. That concludes this mini lecture on hole in the ozone layer, acid rain, and indoor air pollutants. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!